All right, suppose you wanted to solve this absolute value inequality. Number 1, 5x minus 3 minus 2 is less than or equal to, let's say, 7. All right, so on your test Wednesday, if you're given this absolute value inequality, what would be the first thing you would do?
Add 2 to both sides.
Add 2 to both sides. So you got to get the absolute value by itself. And then combine like terms, and I get the absolute value of 5x minus 3 is less than or equal to 9. All right, now at this point, you need to determine, is this an absolute value inequality involving greater than or less than? If it's less than, you're going to rewrite it a certain way. If it's greater than, you're going to rewrite it a certain way. So which one is it?
Less than.
Less than. So with the less than, you're going to rewrite the expression 5x minus 3, and you're going to say what?
5x minus 3.
What are you going to say?
Less than or
Less than or equal to 9, and at the same time, it has to be greater than or equal to negative 9. All right, so you're going to write it as this compound inequality. Okay? Notice when I wrote it, I said this. I said the expression within the absolute value bar is 5x minus 3 has to be less than or equal to 9, and, I use the word and, at the same time, it has to be greater than or equal to negative 9. Okay? So you have 9 and negative 9 on either side. Okay, now, the next step is to use your properties to get the variable x in the middle, so that way you can determine what your solutions are. So what's the next step?
add 3 to all 3 sides.
Add 3 to all parts. Negative 9 plus 3 is a negative 6. Negative 6 is less than 5x, is less than equal to 5x, and that's less than equal to 12. You're probably talking about the other side, yeah. All right, so divide all parts by 5. And so my solutions are going to be between negative 6/5 and 12/5. That's where my solutions are. And how many solutions are there? How many numbers, how many real numbers are between those two numbers? An infinite number. You can't count them. There's an infinite number of real numbers between negative 6/5 and 12/5. All right, now you're going to be asked to put this on the number line. So if this is 0, this is negative 1, this is negative 2, 1, 2, 3. Where's negative 6/5 located? Between what two numbers? So between negative 1 and negative 2, right? Because negative 6/5 is the mixed number negative 1 and 1/5. So it's closer to negative 1 than negative 2. So let's say it's about here.
Bracket.
So that's negative 6/5 right here. Now where's 12/5 located? Between what two integers?
Between 2 and 3.
Between 2 and 3, because 12/5 is 2 and 2/5. So, but it's closer to 2 than to 3, because 2/5 is less than half of it. So let's say this is 12/5. All right, now is negative 6/5 a solution, yes or no? Yes, because of the equal sign. There's an equal sign. So I'm going to use brackets, pointing to the right, and then is 12/5 a solution?
Yes.
Yes, because of the equal sign. Brackets pointing to the, oops, wrong one, sorry, right here. Brackets pointing to the left, and then I shade everything between them, right?
Right.
All right, so there's your graph. So remember, when you graph something, you're graphing the solutions. So these are all the solutions that will satisfy the original inequality. So notice that 3 is not a solution. 3 is not a solution because if I go back and I check it in the original, what's 5 times 3? 15 minus 3? 12. Absolute value 12. 12 minus 2? 10. Is 10 less than or equal to 7? No. As an interval notation, what's the solution set?
Bracket, negative 1/1/5.
Oh, I'm sorry. I said negative 1. I meant negative 6/5, right? No, you can put negative 1 1/5, comma, all the way to what?
2 2/5.
12/5? Okay. All right. Now, number 2. Okay, listen carefully. Number 2. Suppose you had negative 3 times the absolute value of x plus 5 is greater than negative 12. So negative 3 times the absolute value of x plus 5 is greater than negative 12. All right, now remember, you're supposed to get the absolute value by itself. So what are you going to do? Yeah, you're not going to distribute, right? Because that's not parentheses, so don't distribute. All right, so you got to get the absolute value by itself. Right now, multiplying it by negative 3. What's the absolute multiplying by negative 3? Divide by negative 3. Now, let me go ahead and rewrite this over. All right, so I'm going to divide both sides by negative 3, right? Okay. Now tell me what to write. So the negative 3's divide out, so I have the absolute value of x plus 5 is what? Is what? Less than. I divided inequality by a negative number, so I've got to reverse the inequality symbol. So the absolute value of x plus 5 is less than what number? 4. Okay? So I went from this absolute value inequality to this one. All right, now how do I rewrite this one? What's the next step?
You gotta subtract 5 from both sides.
No.
Oh, no.
Okay, so you rewrite as that compound inequality. So the expression on the inside, x plus 5, has to be less than 4. At the same time, it has to be bigger than what? Negative 4. Okay? All right, and then one more step and you're done because it's just an x that you see. So what's the next step? Subtract 5 from all parts. And so I get a negative 9 is less than x is less than negative 1. All right. Now, is negative 9 and negative 1 solutions? No, because there's no equal sign. But any real number between them are solutions. So in the number line, if this is 0, this is negative 1, and let's say this is negative 9, am I going to have brackets or parentheses in those numbers? Parentheses. So remember, it's anything between all real numbers between negative 9 and negative 1. So I'm going to need parentheses pointing to the right here, and then over here pointing to the left, and then shade everything between them. Was the interval notation? Negative 9, negative 1 parentheses? Okay. All right. So that was a review from yesterday with regards to absolute value less than. All right. Now, let's talk about absolute value greater than. Greater than. Okay, so to do that one, let's first of all look at a very simple example. So when we first talked about absolute value less than, we looked at the absolute value of x is less than 2. And we said what would be the solutions? And we used that to come up with a process of solving just a general absolute value inequality that's less than. So for this one, let's look at this inequality. Suppose I had the absolute value of x is greater than 2 instead. Not less than 2, but greater than 2. So I'm going to look at the number line. And let's say this is 0. So give me some numbers whose absolute value is greater than 2. 3. The absolute value of x. The absolute value of 3 is 3, and 3 is bigger than 2. So here's 3. I'm going to put a dot there, indicating that that's a solution. What else? Can you give me any ideas?
-3.
Negative what?
-3.
-3 is also a solution, because what's the absolute value of -3? 3, and 3 is bigger than 2. So -3 is also a solution. Any other ideas? Any general statements you want to make? Say it again. -7 is a solution. So yeah, that is true. Can you make any general statements though? Any what?
Is that greater than 2?
Any number that's greater than -2 or 2.
Okay, he said, first of all, he said any real number greater than 2. Do you agree with that part? So in other words, if this is 2 right here, and first of all, is this going to be parentheses or brackets? Parentheses, because there's no equal sign. So he said this. Is that a true statement? First of all, is everything in that I've graphed, are those going to be solutions? Yes. Okay. Is 0 a solution? No. Is 1/2 a solution? No. Because absolute value 1/2 is 1/2. Is 1/2 bigger than 2? No. All right. Can you make another general statement then?
Less than -2.
No, you say greater than -2. Greater than -2 means this.
Less than -2.
Less than -2. Okay. So here's -2. So he said any real number greater than 2. She said also any real number that's less than -2. Is that true?
Correct.
So the solutions are not between what? -2 and 2. But anything on the other side. Okay? So notice for our purposes, notice the difference between the graphs that we did yesterday and today. Notice that with the less than, it was bounded. There was no arrows, right? With the less than. That's the way it's going to look for us. With the less than, it was bounded, so it was between 2 numbers. With the greater than, you have 2 intervals, 2 sets of graphs. You see the 2 intervals? And remember, you read a graph from where? You read a graph from where? Left to right. So in terms of interval notation, you would say this would be -infinity to what? -2 with a parentheses, and then 2 to infinity. Now, when you did this a couple of semesters ago, not absolute value, but when you dealt with absolute value, I'm sorry, just regular inequalities, remember the union symbol? You may remember the idea of that union. So basically this says this, listen to the words. This says my solutions are, listen to the words, the solutions are from -infinity to -2. They're in that interval, or, hence the union idea, or they are in the interval from where? 2 to infinity. Okay? Now, do y'all agree that what I'm about to write is a true statement? Let's look at this interval right here. Is this the same thing as saying x is less than -2? Do these two things correspond? Yes. Or, let's look at this one. For this statement here, is this a true statement? X is greater than 2. Yes. Okay? So when you're dealing with the greater than, greater, G-R-E-A-T-E-R, right? But pronounce it this way to help you, greater. In the word greater, you hear the word or, right? So greater than, you're going to use an or statement. That's where you're going to separate them. Less than, A and D, less than, A and D, that's that and statement. So that's where the solutions are between them. Okay? All right. So basically, here's the idea. If I rewrite this greater than inequality without the absolute value bars, you see x is greater than 2, right? That's this one here. Then you would say or x can be less, and remember, you always check the opposite. One was 2, the other one was what? Negative 2. Then you would say or x could be less than the opposite of 2. That's this one. All right, so when I get to this point here, number 4, if I have the absolute value of 2x minus 1 is greater than 3, greater than, let's say greater than equal to, greater than equal to 3. So you got to determine, first of all, you got to do the absolute value by itself. Is the absolute value by itself? Is the absolute value bars by themselves?
Yes.
Yes. They're by themselves. So once you get them by themselves, then you ask yourself, is this a less than or a greater than?
Greater.
It's a greater than. So greater, so that's where you're going to have that or statement in two separate inequalities. Less than, you have that compound inequality that's between two numbers. So you would have this. You'd say, all right, my first one's going to be 2x minus 1 is greater than or equal to what? 3. Or 2x minus 1 has to be what? Less than or equal to a negative 3. And then you solve each one and you're basically done. So how do you solve this inequality right here? Add 1 to both sides. You get 2x is greater than or equal to 4. How do you get x by itself?
Divide both sides by 2.
Divide both sides by 2. So my solutions to the original absolute value inequality, one set, would be any number that's greater than or equal to what?
2.
2. So any real number greater than or equal to 2 works. Is 2 a solution?
Yes.
Yes. So let's see why 2 is a solution. Go back to the original. What's 2 times 2?
4.
4 minus 1?
3.
Absolute value of 3?
3.
Is 3 bigger than or equal to 3? Yes. So far in the number line, on the number line I have this. Here's 0, here's 2. Do I need bracket or parentheses?
Bracket.
Bracket. Going which way? To the right. Okay? The other one, add 1 to both sides. I get 2x is less than or equal to what?
Negative 2.
Negative 2. Then what's the next step?
Divide both sides.
Thank you. Divide both sides by 2. I get x is less than or equal to a negative 1. So here's negative 1. Bracket or parentheses. Going which way? To the left. All right. So there's your graph. So remember, when you're dealing with greater than, that's those two separate intervals, those two separate graphs. Arrows pointing in different directions. That's one we're going to deal with. Okay? For us, that's what it's going to look like. Now, what's the interval notation?
Bracket 2.
Nope. Go from left to right.
Okay, go from left to right.
Negative infinity with parentheses to what? Negative 1 with a bracket union,
And then
bracket 2, comma,
infinity.
infinity with parentheses. So that's your greater than. Okay? Number 5. All right, 3 times the absolute value of 4x plus 1 minus 2 is greater than, let's say, 7. Is the absolute value bars by themselves?
No.
Got to get them by themselves before you can determine whether you're going to have two separate intervals or one interval. What's the first step?
To add two both sides.
Add 2 to both sides. No, don't always do the division last. Add 2 to both sides. Combine like terms. I get 3 times the absolute value of 4x plus 1. That's plus 1. Is greater than 9. Then what's the next step?
Divide both sides by 3.
Divide both sides by 3. I'm going to go ahead and rewrite this over. All right, when I divide both sides by 3, I get the absolute value of 4x plus 1 is greater than 3. All right. Now, is this going to be a less than or a greater than? Greater than. So greater, that's that or statement. So think or and then 2 intervals. So write the first inequality. It's going to be 4x plus 1 is what? Greater than 3. Or 4x plus 1 is less than negative 3. All right. A few more steps and you're done.
Solve both sides.
So let's get x over here. Here you're going to subtract 1 from all parts. So 4x is greater than 2. Dividing by 2. My solution would be any number that's bigger than what? Go ahead and reduce.
1/2.
1/2. So that's one set. That's not the only set of solutions though, because you remember you want to list all of them. That's only part of it. So far my graph looks like this. So here's 0, here's 1, here's 1/2. Parentheses or brackets? Parentheses going which way? To the right. Don't forget your arrows. Draw your arrows. All right, so there's one of them. All right, let's do the other. So in the other inequality, you're going to subtract 1. So I get 4x is less than negative 4. I'm going to go ahead and rewrite this over. And then what's the next step?
Divide both sides by 4.
So my solutions would be any real number that's less than what?
Less than negative 1.
Negative 1. So you can put negative 1, bracket or parentheses on negative 1. Parentheses going which way? To the left. All right? Don't forget your arrows. So you graph your solutions. So my solutions are from negative infinity to what? Negative 1, union, and then from what? 1/2 to infinity. Okay? All right, number 6. Number 6, suppose you had 3 minus 2x is less than, let's say, 5. The absolute value of 3 minus 2x is less than 5. All right, is the absolute value by itself? Is the absolute value bars by themselves?
Yes.
Yes. So at that point, that's where you're going to split them. You're going to get rid of the absolute value bars. Once they're by themselves, the next step is to get rid of the absolute value bars. Now this is a less than. So that's not that or statement, right? So here you're going to write it as that compound statement. Notice I use the word and, less than. So you're going to say 3 minus 2x is less than 5. And at the same time, it has to be greater than what? Negative 5. All right? And then all you got to do is get x by itself in the middle. So what's the next step? Subtract 3 from all parts, just like this, and then combine your like terms. Negative 5 and negative 3. Negative 8 is less than negative 2x. Negative 2x is less than 2. remember yesterday towards the end of the period, I think it was the very last one we did, someone asked about, well, what if there's a negative in the middle? Remember we did one like that yesterday? So that's what we're at right now. So what's the next step? Divide by -2. I'm going to go ahead and rewrite this over. So I'm going to divide all parts by -2. Now remember though, what am I doing? Dividing by a negative number. So what else must I do? Reverse the inequality symbols. So -8 divided by -2 is 4. 4 is going to be greater than x, and at the same time, that x value has to be greater than what? -1. Okay? All right. Now, on the graph part is easy in terms of the way this looks. So in the number line, you have -1 and 4. So this says that all my solutions are between what two numbers? -1 and 4. That's what that says. On -1 and 4, I'm going to have parentheses or brackets. Parentheses. So they look like this. Make sure you put the parentheses on those numbers, and then shade between them. Okay? Now, you need to be careful with the interval notation. If you use this right here, that inequality statement, do I put 4 first or -1 first? -1. So just note this, that when I say that 4 is greater than x and at the same time is greater than -1, that means the same thing as -1 is less than x and that x value is less than what? 4. Those two mean the same thing. And so notice this looks more like this now. See this right here? That looks more like this. So in interval notation, what's the answer? Yeah, you just read it from your graph. So see the graph, you just rewrite it. -1 comma what? 4 with parentheses. All right, and then number 7, let's do one more. Number 7, suppose we had -5 times the absolute value of 2 minus x is greater than, I'm making this up, let's do less than, I'm sorry, less than 4. Nope, I don't want a fraction, I don't want a fraction.
Which is it?
Let's do -10. -10. -10.
I mean, the symbol, what's the?
Oh, less than. So -5 times the absolute value of 2 minus x is less than -10. Okay? All right. What do you have to do first? Get the absolute value bars by itself. So what's the first step? Divide both sides by -5. So I'm going to rewrite this over. Divide by -5, divide by -5, and I'm dividing by a negative number. So remember, you divide or multiply both sides of an inequality by a negative number, you have to reverse the inequality symbol. So the -5s divide, and it gives you 1 here. 1 times the absolute value of 2 minus x is the absolute value of 2 minus x. So I have the absolute value of 2 minus x is what now?
Greater than 2.
Greater than 2. Right, so that's where I'm at. Okay, so is this going to be 2 intervals that I'm dealing with or 1 interval? 2. So great or that or statement. So 2 minus x has to be what? Greater than 2, or 2 minus x has to be less than a -2. And you just solve each one individually and you're done. All right? All right, let's look at the first one. What are you going to do first over here? Subtract 2. So when I subtract 2, I get -x is greater than 0. Okay, that's where I'm at now. I've got to get x by itself. I don't have x by itself. So it's,
By -1.
All right, so think of negative x as negative 1 times x is greater than 0. So to get x by itself, you can divide both sides by negative 1. So hence I'm dividing by a negative number again. Reverse the inequality symbol. So that means then that all my solutions are going to be less than 0, because 0 divided by negative 1 is 0. So that's one part of my solution, though. It's not all of it, it's just one part. So any real number less than 0 is going to make the original absolute value inequality a true statement. All right, let's look at this one. Here, what do you do?
I might subtract negative 2 from both sides.
Subtract 2 from both sides. So I get negative x is less than negative 4. Right? Negative 2 and negative 2 is a negative 4. So I'm going to rewrite this as negative 1x is less than negative 4. So what's the next step? Divide both sides by negative 1. Remember, I'm dividing by a negative number. I've got to reverse the symbol. So negative 1 divided by negative 1 is 1. 1 times x is x. So tell me what the other solutions would be. Any real number greater than 4. Okay? So your number line, you have 0 and you need 4. So in 0, parentheses or brackets? Parentheses going which way?
Going less than.
To the left. So x is less than 0, this is x is less than 0. So any real number less than 0, that's what I just shaded. That's what I just grabbed. Here, this would be any real number greater than what? 4 with parentheses. All right. And then, what is your interval notation?
Parentheses, negative infinity, comma, 0.
Parentheses, union,
Parentheses.
4 to
comma,
infinity. Now, in my math lab, when you do my math lab, you're not going to put a union, you'll just put a comma. So you'll say negative infinity to 0, comma, and then 4 to infinity. Okay? That's the way it's going to tell you to do it. Just separate the parentheses using a comma. All right. So that's the end of the absolute value inequality. Very straightforward. You just got to practice. Okay? All right. So let me give you the worksheets dealing with this.